What is up, kabsat? And today we are on our third daily problem solution by LAD's Engi-Math Scribbles. So kung gusto niyo makita muna yung problem, check the description below. Andyan yung link dun sa original post. Okay? So ito yung ating problem. It's on statics. So we are asked to determine the magnitude of a component of the given force. Given yung force niyan, 3D yan. So we have the I, J, and K components. That is, which are all in newtons. And ang kinukuha natin yung component ay yung perpendicular to the member CB. So given dito sa ating figure, merong part dyan na CB. Kukunin daw natin yung magnitude ng kanyang component. Right. So 3D siya. So it's a bit hard if we try to solve this one by geometry and trigonometry dun sa mismong figure. Lalo na dito sa figure na to, hindi pa nakascale yung buong figure, di ba? Hindi pa nakascale yung force. So, it's a bit hard, or it's actually hard, kung itatry nating isolve yan na ganyan lang. So, what we are asked to do, syempre, kailangan elegant yung ating pag-solve para hindi ganun kahirap tignan, hindi ganun kahirap intindihin, and dapat yung madali lang. 'Di ba? Of course, doon tayo sa madali lang at mabilis lang na solution. So, anong pwede natin gamitin? You heard it? Vectors. So, vectors yung gagamitin natin. Total, naka-vector form na din yung ating force. Right? 'Di ba? So, let's consider two random vectors. For example, itong vector na to, let's call it A. And then, merong vector dito, let's call it B. Ngayon, kunin natin, syempre, since yung ating problem dito, perpendicular component perpendicular to a given vector ulit. So, kunin natin, para makuha natin yung component na to, let's say, C? Oops, bakit A? Alright, so C. Sabihin natin C yung ating vector na yan that is perpendicular to the vector A. Paano? Di ba may angle dyan? So, nangyari, yung magnitude niya, tama? Yung magnitude na nung ating vector dito, magnitude of vector C, is what? The magnitude of vector B sine of theta. Correct? Right. So, yun nga. Ito yung magnitude na ng ating vector C, which is the perpendicular component of B na perpendicular sa kay A, no? So, magnitude nito nung C, magnitude nung B, sine of the angle. So, we actually have to recall that sine of theta is actually sine of theta is the the cross product of B and A over the product of their magnitudes. Yan. So yan yung sine of sine of the angle between the two vectors. So substitute lang natin. Right? So yan, magnitude of C is equal to the magnitude of B times the magnitude of the cross product of A and B all over the magnitude of B times the magnitude of A. So, syempre, may makakancel, di ba? Cancel yung magnitude ni B. And then, tong si magnitude ni A, pwede naman nating i-divide kay vector A dito. So, we have the cross product magnitude of the cross product of B and what? Vector A over its magnitude. So that is the unit vector. O, diba? Madali lang siya. Unit vector. So magnitude of the cross product of B and the unit vector of A. So yun ang kailangan natin gawin. Apply lang natin sa ating problem. So, for the perpendicular component, let's say ano na lang, F perpendicular to BC is equal to what? The magnitude of the force, that is F, cross product with the unit vector of BC, U, BC. Diba? So, meron tayong force, kailangan na lang natin yung kay BC. Okay? So, ang gagawin lang natin, kunin muna natin yung coordinates ni B and C. So, for the coordinate of B in the given figure, syempre yung X is 3, Y is upward, so 4, and then Z is 0. Hindi naman kasi siya humarap or pumatalikod. And then the coordinate of C is X is 2, Y is 0, and Z is 3. Right? So, syempre, positive na yung mga coordinates dahil they are going to the direction nung label. Yun lang yung actually yun yung basis ko. Though, pwede namang hindi. Pero, it's easier to understand, di ba? So, now, for the vector BC, subtract lang natin yung position vectors ng B and C. Or actually, para mas madali nating maintindihan, mag-subtract lang tayo ng coordinates. Subtract lang talaga natin yung coordinates. We have two, syempre, wait lang. Syempre for the vectors for vector BC, mauunang isusulat natin yung sa coordinate ng final point. Ang initial point natin dito ay si B, final point si C. So, C minus B, kumbaga, no? That's 2 minus 3 I, diba? 2 minus 3 plus 0 minus 4J, that's for the Y coordinates, and plus 3 minus 0K. So the vector BC is equal to negative I minus 4J plus 3K. Then, let's have the magnitude of BC. More like a 3D Pythagorean theorem siya. So we have square root of negative 1 squared plus negative 4 squared plus 3 squared. The value here is square root of 26. So therefore, the unit vector BC is equal to negative 1 over square root of 26i minus 4 over square root ng 26j plus 3 over square root of 26k. And then, ayun, kunin na natin yung cross product, no? So, F perpendicular to BC is equal to the determinant muna. So, ito, ano muna to Ayan, sorry, nakalimutan kong lagyan ng label. Ayan, vector muna siya. So, mamaya na yung magnitude. So, we have I, J, K. But if you can recall, cross product, no? Then, we have 120 here, 30 for the J, and 44K. This is for the force. And then, for the unit vector, we have negative 1 over 26, square root of 26, negative 4 over square root of 26, and 3 over square root of 26. And if we try to simplify this one using, ikaw na bala kung anong gusto mong method yung pagkuha ng determinant ng 3x3 matrix, pero ang magiging determinant ay ayan. So sinulat ko na, no? So ito yung kanyang determinant. It's in the vector form kasi cross product. So therefore, the magnitude of that cross product is equal to Pythagorean theorem ulit na 3D. So gamitin mo lang same concept with this one. So square root ng ito, lagyan lang natin square root of this squared plus square root of this squared plus sorry, wala nang square root pala. The square root of this part squared plus this component and this component squared. Alright? Kaya na bala, calculate nyo na. And that magnitude is equal to, that's approximately 127.852, and that is in newtons. So yan lang po pagkuha niya, no? Okay, let's make a deal, no? Our agreement. Ang pinakita ko po, guys, ay yung pagkuha lang nung mismong vector. Some portions, like yung determinant ng matrix, yung pag-substitute sa calcu, hindi ko na pinakita. It's up to you to verify. If my answer is wrong, comment nyo lang, no? And I'll make a separate video. Then, actually, some of you may give a comment regarding a faster way to solve for the cross product by just using your calculators. Hindi ko na rin pinakita because, it's a calculator technique naman. So you can, you can discover it on your own, no? Ang pinakita ko lang, guys, yung method talaga kung paano ang importante kasi yung makuha nyo yung bakit cross product. Alright? So, bakit ganito yung naging formula na cross product? Bakit hindi ganitong dalawang forces yung ginamit, ganitong vectors, no? So yun, I hope may naintindihan kayo, guys. This is the third problem under statics. So that's it for me. I'll see you soon. Nga pala, check nyo na lang po yung description for more details. You can follow me on your socials. Join us on the Facebook and Discord groups. Follow me also dun sa isang YouTube channel pa. Support the channel. Lahat ng yon, all details nasa description. So, thank you guys for listening and watching. Share this to your friends. I'll see you guys soon. Have a good one.